This is Algebra Lesson 10-1, Exploring Quadratic Graphs. A quadratic function is a function that can be written in the form of y equals ax squared plus bx plus c. This is the standard form for any quadratic function. For example, we might have something like y equals 2x squared minus 3x plus 4. That would be the standard form of a quadratic function. The quadratic parent function is the simplest quadratic function, y equals x squared. A parabola is a U-shaped curve that is the graph of a quadratic function. All quadratic functions are parabolas. The axis of symmetry is a fold or a line that divides the parabola into two matching halves. In other words, if you fold it along the axis of symmetry, the one half would equal the other half if they line up and lay on top of each other. The vertex is the highest or lowest point of a parabola. It is always on the axis of symmetry. In a parabola, if a is greater than 0, in the form of y equals ax squared plus bx plus c, the parabola opens upward and the vertex is a minimum point. In other words, the parabola will look like this. It will be U-shaped like this, and the vertex down here will be a minimum point. It will be the lowest point of the graph. In a parabola, if a is less than 0, y equals ax squared plus bx plus c, the parabola opens downward like this, and the vertex is a maximum point. In other words, it would be the highest point on the graph, which looks something like that. We're going to graph y equals x squared and y equals 3x squared on the same coordinate plane. We're going to use a different color for each. I would suggest you use a pencil for one and colored pencil for the other. The first thing we're going to do is just make a little snippet of an x and y table. Okay? And we don't need the middle portion. In y equals x squared, I'm going to generate quite a few points because it's going to make it easier. So I'm going to use -2, -1, 0, 1, 2. If x is -2, -2 squared is +4. If x is -1, -1 squared is 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. So if I was to draw an x and y axis, and I'm going to have my x and y axis be down here because I already know some things about this graph that you don't know. Okay, so here's my x-axis, here's my y-axis. I'm going to graph this first one in blue. So -2, +4, 1, 2, 3, 4. Over here, -1, +1, 0, 0, 1, 1, and 2, 4. So here's my parabola of y equals x squared. It looks something like this. It's a U-shaped parabola, y equals x squared. That's our parent function, the parent quadratic function. Now I'm going to use purple to do y equals 3x squared. Again, I'm going to make a small quick table of values. I'm still going to use -2, -1, 0, 1, and 2. So if x is -2, -2 squared is 4. 4 times 3 is 12. If x is -1, -1 squared is 1. 1 times 3 is 3. If x is 0, 0 times 3 is still 0. If x is 1, 1 squared is 1 times 3 is 3. If x is 2, 2 squared is 4 times 3 is 12. So I have these points on the graph. -2, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -1, 3, 0, 0, 1, 3, and 2, 12. So here is my second parabola. And we can take a look at these, and we can see that the parent function and the parabola of y equals x squared, they're alike because they both have the vertex is at 0, 0. Okay? The vertex is at the x-axis. Okay? They're both U-shaped graphs with the lowest point of the origin. Okay? And they're different in that the purple graph is a lot skinnier than the blue graph. Okay? It's narrower. So that's how we can tell the difference between the two of them. And we're going to notice that, if you notice, this one is multiplied by a factor of 3, which makes it go 3 times higher. Where this was 1, 1, this became 1, 3, so it was 3 times higher than the other graph. So when we multiply it by a number in front of the x, it does make your graph a little bit narrower. We're going to learn a little bit more about our quadratic graphs later about that. Okay, you should be able to take a look at a quadratic graph and be able to give me the vertex and tell me whether the vertex is a maximum or a minimum. Okay, so if we look at this particular graph on the left here, the blue graph, we can see that this is our vertex right here. This point right there is the lowest point of the graph, So that vertex happens to be a minimum point, and that vertex is at the coordinate 1, -4. So my vertex is 1, -4, and it's a minimum point. In this second graph here, this black graph, my vertex is right here. Right? And we can see that it is at 7, 1. Okay, so the vertex is at 7, 1. And this is a maximum point because it's the highest point on the graph. The graph goes downward from there, so the highest point is at the point of 7, 1. Okay, so being able to find and label maximum and minimum points is important. Now you can use the fact that a parabola is symmetric to graph it very quickly. I did that when I did the first one. First, find the coordinates of the vertex and 1 or 2 points on either side of the vertex, and then reflect those points over the axis of symmetry. For functions in the form of y equals ax squared, the vertex is always going to be at the origin. So let's make a table of values and graph a couple of quadratic functions. Let's take this first one. And I'm just going to make my tables right here. So here's the table for column number 1. If y equals 1/3 x squared, okay, I'm going to use a couple of points, and I'm going to use multiples of my denominator of 3, so I'm going to use 0, 3, and 6. I'm not going to use any negative points because I really don't need to, because we'll understand why in just a moment. Okay. If I take 1/3 times 0, I get 0. Okay. If I take 1/3 times 3, well, I have to square 3 first. 3 squared is 9. 1/3 of 3, excuse me, 1/3 of 9 is 3. If I take 6 and I square it, 6 squared is 36. 1/3 of 36, or 36 divided by 3, is 12. So I have points I can graph now on my lovely x and y axis. So I'm going to, since I need to go up to 12, I'm going to put my x-axis way down here. And I'm going to put my y-axis way back here. Always label your axes. So I'm going to plot the point 0, 0. I'm going to plot the point 3, 3, 1, 2, 3, 1, 2, 3. And I'm plot the point 6, 12. 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you might say, but you only have half the graph. You're right, I do. But the axis of symmetry, what makes the graph symmetrical on each side, is the y-axis. So if I plotted a point here that was 3 units to the right of the y-axis, I now need to plot a point that is 3 units to the left of the y-axis, so 1 and 2. So here's my mirror image point. You're mirror imaging them. So if I have this point up here, which is 6 units away from the y-axis, I'm going to go 6 units away from the y-axis in the other direction. 1, 2, 3, 4, 5, 6. I put my other point here. Now I can draw my graph with a nice smooth curve. Easier said than done, because I'm not very good at drawing. And there's the graph of y equals 1/3 x squared. They're not hard to graph once you have at least 2 to 3 points. Let's take a look at y equals -2x squared. Let me graph this one in green. Make my little x and y table over here. Since I do not have any fractions, I can choose whatever numbers I want. So I think I'll use 0, 1, 2, maybe 3. If x is 0, y is 0. If x is 1, 1 squared is 1 times -2 is -2. Okay, if x is 2, 2 squared is 4. 4 times -2 is -8. That's probably enough points to be able to get a decent graph here. Okay. I already know that this number is negative, so I already know that my vertex is going to be a 0, 0, and that's going to be the maximum point of my graph. Because I already know that it already said in the definition that if a was greater than 0, that was your minimum point. If a is less than 0, that's a maximum point. So I have 0, 0 right here. I have 1, -2, which is here. Its mirror image will be 1 unit over here. I have 2, -8, 1, 2, 3, 4, 5, 6, 7, 8. So that is there. Its mirror image is going to be 2 units over from the y-axis over here on this side. So I now have everything I need to graph this graph. And this is the graph of y equals -2x squared. So they're not hard to graph if they're in parent function.
Hey, Sean and Jake, if you're still on campus, I'll be.
moving on. Notice how the value a, the coefficient of the x term in the quadratic function, affects the width of the parabola as well as the direction which it opens. Notice in this first one, we had a was 1/3, so that was very wide. We had a very wide graph. Here, a was -2. It was not a fraction. It was a whole number, so this became very narrow. So if our a term is a fraction, our graph is really wide, and if our a term is a whole number, our graph is fairly narrow. And if our a term is positive, the graph opens upward, and if our a term is negative, the graph opens downward. Okay. The y-axis is the axis of symmetry for these functions in the form of y equals ax squared plus c. The value of c translates the graph up or down. Let's take a look at that. Okay, let's graph y equals 3x squared plus 2. Again, we're going to make a table of values. Doesn't have to be a very big one, but we're going to make a small table of values to be able to figure this out. So if I make a little table of values here, let's say I'm going to choose 0, 1, and 2 again. X is 0, 0 squared is 0, times 3 is 0, 0 plus 2 is 2. X is 1, 1 squared is 1, 1 times 3 is 3, 3 plus 2 is 5. If x is 2, 2 squared is 4, 4 times 3 is 12, 12 plus 2 is 14. All I'm doing is putting these numbers in for x and solving the equation. We've done this before. This should not be new to you. Okay. I see I need to go up all the way to 14, so I know I'm going to need my x-axis way down here. I'm going to draw my x-axis down here. That is not a very good x-axis. Okay. Maybe I should justify our line here. Okay, there's my x-axis. There's my y-axis. X, y. And my graph is in red. 0, 2, 2, 1, 5. 1, 2, 3, 4, 5. So its mirror image is going to be over there. And 2, 14. 1, 2, that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to do its mirror image over here. So there's the graph of y equals 3x squared plus 2. Notice the plus 2 moved my graph 2 units up from the x-axis. So in the graph of y equals 3x squared plus 2, the 3 made it narrower, and the 2 here, and the 2 at the end, moved the graph up 2 units. And we talked about this when we translated absolute value graphs. Remember, this was a horizontal translation, or a vertical translation, excuse me. A vertical translation, in this case, positive 2. Okay, if we have y equals 3x squared minus 2, I can do the exact same thing over here. Make a little x and y table. Still use 0, 1, and 2. If x is 0, 0 squared is 0, times 3 is 0, minus 2 is negative 2. If x is 1, 1 squared is 1, times 3 is 3, 3 minus 2 is 1. And then if we have if x is 2, 2 squared is 4, 4 times 3 is 12, 12 minus 2 is 10. Okay, so those are the points that I need to use. And now I can graph these. So if I was to graph these, let me try to draw my x and y axis. I know there's my x-axis. And my y-axis. 0, negative 2 is here. I want to put my axis too low. Okay. 1, 1. 1. That's mirror image. 2, 10. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's your mirror image over here. And there's the graph of y equals 3x squared minus 2. You'll notice minus 2 meant the vertex dropped 2 units from the x-axis. It dropped 2 units from 0, 0, which is exactly what it did. So y equals 3x squared minus 2. And this is all about just exploring what quadratic graphs look like. You have to graph them. You should be able to give me the vertex. In this case, my vertex is 0, negative 2, because that's where this point is, right down here. It opens upward. It's a skinny graph. We'll explore more about these graphs in coming lessons.